morning, second period.
Good morning.
We are recording. So today we're talking about the logic of true and false. We're recording. We're recording.
I was reading
I know.
in Spanish.
Nice. So we're talking about the logic of true and false. Please make sure your notes are set up this way. You definitely need stuff to write with. Again, we're not doing any drawing, so you don't need protractor or compass today. I'm going to recommend that you have some different colored pens or pencil colors or highlighters. If you don't have them, that's okay. But these are the three that you're going to see me use today. All right. So yesterday we talked about those conditional statements, those if-then statements, right?
Yes.
Okay. Well, today we want to start talking about what happens when we have statements that have this kind of true-false thing set up to it. Okay? So let's look at an example. Is this statement true or false? Austin, Texas is the capital of Texas.
Yes.
True or false?
True.
That's true. It's true.
That's true because Austin is in Texas and it's
This
the capital
Austin
of
is
Austin.
spelled. It's not that.
It is.
We got you.
Thank you. Austin, is it the capital of Texas? Yes or no?
Yes.
So is this statement true or false?
True.
True. You're right. It's true.
Of course,
Austin is
Miss, I'm right. I'm
the
always
capital.
right.
Gorgeous. What about this statement?
Hey, Miss, who's gorgeous? Me?
Mm-hmm.
Well, of course it was me.
Is this statement true or false? Birds fly.
False.
How's it false?
Not all birds fly.
Not all birds fly? Give me a counterexample.
Penguins.
Penguins.
Flamingos.
Flamingos fly.
Chickens.
Chickens fly. Chickens do fly.
Ducks fly.
I have nearly been hit in the face with a flying chicken. And it wasn't like someone chunked a chicken leg at my, like piece of fried chicken at me. No.
I think that was it. No, there's a black chicken.
I like fried chicken.
Yeah, it was like an actual real life chicken with feathers and everything kind of flew.
You've
They don't
never
fly
seen a
far,
chicken
they
fly?
don't fly well, but they fly enough to try to hit you in the face.
Yeah, it's like, no, that's a jump.
That's a joke. We're falling with style, right?
Falling with style.
All right.
Gliding.
So you heard me ask when you said that it was false that birds fly. You heard me ask for a counterexample, and you told me that penguins was a counterexample because penguins don't fly. So the question I have for you is, what was that counterexample? What's the definition for counterexample?
Put it the other way
Put it the other way
and negate it.
and negate it. Okay, that's like an inverse. Yeah, from yesterday? Yeah. What would be that counterexample? Because here, the sentence that you gave me, penguins don't fly, that didn't negate this statement. This wasn't birds do not fly. This was telling me that here's a bird that doesn't fly.
If it would have said, do all birds fly, that would have been false. 'Cause it didn't get there.
You're right. And since this one doesn't have any all, some, none, we have to assume it's all of them. Yeah?
You can put,
And so we
if
were
you put most birds fly, then maybe that would be true.
Yeah, and we're about to talk about this, which I love. So hang on to that thought for a second. The question right now is I had asked for a counterexample when you told me that statement was false. And you gave one. The counterexample you gave me was that penguins, which are a type of bird, don't fly. So I'm asking, what's the definition of counterexample?
Not all birds want to be true.
Not all birds.
That's this specific counterexample. What's a counterexample in general? If I gave you any statement that you were trying to decide whether it's true or false, and I said, give me a counterexample, what kind of thing are you going to go looking for?
Birds
Like
of flag.
something that is true but has a
Birds of flag.
obvious statement wrong.
Okay, so something that's related to that statement, like here we're talking about birds, and so penguin is a kind of bird, that makes the statement false. In this case, your example of, well, penguin's a bird, but it doesn't fly, and the statement was the birds fly. Okay, so we'll write that a counterexample is
How is that false? Oh, never mind.
an example of the statement
Oh, I can't see.
being false.
Why do I have to wear glasses?
And here's the trick is with a counterexample. Because you guys are now all geometry lawyers,
I am.
you are. I have inducted you. You've passed my bar.
Not a lawyer.
I always wanted to be a lawyer.
You are one now in my geometry class.
I don't like this.
All it takes when you are looking at these arguments and you're trying to line up this really great argument, all it takes is one counterexample. One example that your statement is false and everything that you've done is false.
Oh, like when they do it in movies when like they argue back and forth about like one thing and
Exactly, and you find that one tiny
debating.
thing.
There you go, the debating.
Exactly, okay? So this is that example of that, okay? All right, now what you guys had been talking about before, and I'm going to zoom in here on my main writing area, where you had said if we change that sentence to most birds fly, which would suddenly be a true statement, because that's not all of them, right? That's just most of them. This right here is called a qualifier. That qualifier helps change the value of the true false of this statement. The other qualifiers are like all, right? If I said all athletes play football,
No.
no. Right, and then our poor volleyball girls are going to get all up in arms and they'll probably kick our butts. If this, they're going to gang up on us.
They butch.
There could be none, which the athletes play football, using the qualifier none. No athletes play football.
What
Or,
about,
yeah, it's
boy
kind of weird.
athletes? play football?
Some athletes play football.
Yes.
Okay? So you can see those qualifiers in there to help you decide on those true-false things. Okay, so far so good? All right. Let's go in and start playing around with some truth values. You know how in English writing class, you learned that you can combine two sentences together?
Yes, ma'am.
Like if I had the word cats are furry, or the sentence cats are furry, and then I had another sentence that said birds have feathers, and you wanted to combine that and make one sentence, you'd put cats are furry
And birds are feathers.
and birds have feathers, right?
I said birds of feathers.
Birds have, yeah. Right? You can do things like that. You can do the same thing here with logic statements, but it makes this whole true-false thing that we just finished talking about change slightly. So let's look at what and or talks about, and then we'll go in and do those truth tables to make it make more sense. Have y'all heard the nursery rhyme, Jack and Jill?
Jack and Jill went up the hill to fetch a pail of water. Jack fell down and broke his crown, and Jill went tumbling after.
Lovely. There's the whole nursery rhyme. We're going to look at just the first sentence of that nursery rhyme.
You're too famous!
We're going to look at just the first sentence. Jack and Jill went up the hill.
Aw,
Okay.
I'm only for that.
This is a compound statement. There's two sentences that you could make out of this one sentence. Yes?
Jack and Jill.
We have Jack went up the hill,
Jill went up the hill.
and you have the sentence, Jill went up the hill.
But then that makes the song no more sense.
Yeah.
Jack went up the hill, and then Jill went up the hill.
Right, so in terms of the nursery rhyme, doing it like this breaks the nursery rhyme, okay? So we're just going to focus on the sentence, okay? And forget the nursery rhyme for a second. All right. So we're going to look at this. Jack and Jill went up the hill. All right. What if it's true that Jack goes up the hill, but it's not true that Jill went up the hill?
Why?
Okay? So Jack goes up the hill, but Jill does not. Is the sentence, Jack and Jill went up the hill, true?
Yes.
No, only Jack.
No. Only Jack.
Why?
Jack and Jill.
Because the sentence says, Jack and Jill went up the hill. So what does that mean?
Jack and Jill
They
went up.
both go up the hill. But if we break it apart and if we look at these two sentences and say, yes, Jack went up the hill, but no, Jill did not, does this sentence, Jack and Jill went up the hill?
No.
No.
It's not true. Because they didn't both go up the hill. Only Jack went.
But why would it say Jill went up the hill?
This is a statement, and we're checking to see if each statement is true or not.
So it would be Jack went up the hill, and then Jill. It wouldn't be because Jill went up the hill.
Right.
Straight up confused me, but okay.
Okay. All right. So with and statements, I put the and in the wrong place, I'm sorry. With and statements, with and logic statements, both statements, so both parts of the statement, must be true for the entire statement to be true. So in this case, it had to be true that Jack went up the hill, and it has to be true for Jill to go up the hill in order for the sentence, Jack and Jill went up the hill, to be true. Okay? So far, so good?
So far, I'm halfway there, but
Halfway there. Okay. What if I change the sentence? It's no longer Jack and Jill goes up the hill.
Jack or Jill went up the hill.
It's now Jack or Jill went up the hill. And then I say, it is true that Jack went up the hill, but it is not true that Jill went up the hill. Is the sentence, Jack or Jill went up the hill, true or false? Why are you saying it's true?
Because it's saying or, like either or went up the hill. It's not saying and, like they both went up the hill together. It's just saying one of them did.
Fantastic. That's exactly it. With an or statement, it doesn't matter which one of them are true.
Wait, okay. Wait, so,
If even one of them is true, the entire sentence is true. Yes, ma'am.
okay. Wait, so, makes no sense, but why can't Jill go up the hill?
We could switch it. We can say Jack didn't go up the hill, but Jill did. So,
So either one can, like, go up the hill. Okay,
I'm
now
with you.
I get it.
awesome. And with an or statement, it makes the whole thing true.
Okay.
All right, so let's jot that down. So, with or logic statements. Ooh, let's spell statements right. Only one statement needs to be true for the entire statement to be true.
My hair's dry.
Oh, I'm sorry. I didn't realize I was writing off the screen. Sorry about that.
Wait, how do you pull that down?
Give me a thumbs up when you have it all written. Thank you.
Right now I'm gonna like jacket paper too, so I can't really see even though I'm wearing the glasses.
Okay, no problem.
Miss, did you sew your shirt? You can tell you sewed it. You so good.
Thank you.
You sewed it or your mom sewed it?
I do.
You sew really good. Why was it?
Got it? Got it? Okay, so thank you. Thank you for thumbs up. Thank you. Thumbs up. Thank you. Thank you. Thank you. Thank you. Thank you.
Yes, needs to be what?
Needs to be true. Needs to be true.
I wish I wasn't about that.
Thank you. Thank you. All right, I'm going to scoot it up just a little bit. There we go. Now we're going to talk about truth tables. So we had two statements here, yes? We had the statement Jack went up the hill, and then we had the statement Jill went up the hill. So I'm going to abbreviate these statements by using the letters P and Q. Okay, and I'm going to make a little table. So here's my truth table. All right, so I'm going to abbreviate. We're going to use P and we're going to use the letter Q. Now, P is any statement you want to make. Cats have fur. And Q is some other statement you want to make. The sky is purple. Okay? And right now, we don't care what the statements are or whether they're true or false or not. They're just random statements. Okay? All right. Yes. Come on in, drop it off on this empty desk. Thank you very much. And we want to ask, what is the truth value if P and Q? All right. If P is true, okay, so whatever sentence we have in there for P, if it's a true statement, and if whatever sentence we have in for Q is a true statement, what is the truth value for P and Q? It's also true. Right? Awesome. If the statement for P is true, but the statement for Q is false, P and Q. False. Why is it false?
Because only one moves right.
Beautiful. It's false because only one of those two statements is true. And for an and statement, both of them have to be true for the whole thing to be true. All right, what if P were false and Q were true? False. Lovely. And if both of them are false?
Good.
It's false. Because the only time the entire statement is true is when both are true. Beautiful work. All right. Let me try to trick you. Let's do the or. Okay? Let's do the or. P is true, Q is true. What's the value for P or Q? It's true because one of them is true. P is true, Q is false. The truth value for P or Q is? Which is it? Is it true or false? We have a disagreement. It's okay. Discuss. Those of you who are saying true, why are you saying true?
Because it's or, one of them has to be true.
Because it's or, one of them must be true. Those of you saying that it's false, why are you saying it's false? Because one of them is false. All right, let's go back up to the or statement real quick. With or statements, how many do you need to have in order for the whole thing to be true?
Oh,
All? Is it all?
only one.
Only one.
Told you.
All right, so how many do you have that's true here?
One.
So is the whole statement true or false? Good job. It's true. Let's look at the next one. True or false? It's true. Why is it true? Because there's one true. What about the last one?
False.
Why is it false?
Because all of them are false.
Because both of them are false. Nicely done. All right, I'm going to try to make this super hard. Okay? We're going to make it super duper hard. This little squiggly line right here is not. Okay? So, not P. What's the current truth value for P? Right here. This is true. So not means make it the opposite. What's the opposite of true? So then my not P right here would be? Beautiful. And this next one? Yes, and the next one? And the next one? Lovely. All right. You ready? Not P or Q. All right? What's the truth value for not P? What's the truth value for Q?
True.
All right, so not P or Q, your final truth value is?
True.
Why? Because there's one true in there. Good job. Next one. Next truth value, true or false?
True.
This
I mean,
one's
false.
false. The next one,
True.
awesome.
True.
And the last one.
True.
Beautiful. Be prepared for a skill check on this type of thing. Okay? Coming up within the next few days, maybe early next week,
We're going for the 6 weeks?
right before the 6 weeks, okay?
We're going for the 6 weeks?
Yes, I want it to go in for the 6 weeks. Okay? More than likely also will cover those conditional statements, so that you doing that homework, right, that classwork, right before Tuesday is going to give you the practice you're going to need so that you can make that skill check go really fast for yourselves. All right? All right.
Is that it?
That's it. You're done.